We're finding an equation for the tangent line to the graph of f of x equals 3 over x and x equals 6. So whenever we write an equation of a tangent line, we need x, y, and m. So let me write those down. We know what x is. They gave us x is 6. I need to know what y is, and I also need to know what m is. Once we find these three ingredients, we're going to plug them into the point slope form. We can quickly find what y is. Okay, y is simply f of 6, right? Y is the value that we get when we plug in that x into the function. So that's going to be 3 over 6, and that simplifies to half. So we know that y is half. It's going to take us some work to find what the slope is, but slope, m is going to be the value that we get when we plug in that 6 into the derivative function. We don't have the derivative function just yet, so we're going to go ahead and find that. And once we find that f prime of x, then we will plug in 6. Okay, so that's the plan of this problem. Let's write down the limit definition of derivative. At this point, we don't know the quotient rule, so we have to do it the longer way, the difference quotient method. So write the definition down. The derivative f prime of x is equal to limit as h approaches 0 of the difference quotient. So we will have to find the difference quotient, simplify it all the way, and plug in h equals 0 when we are done. Okay, so let's do this part first. I'm going to do f of x plus h first. That's going to be, well, you know what? I don't think the fraction bar has to be that long. Let me write this a little bit shorter. I have to plug in x plus h into this x. See, that's what I need to do, right? So that will turn into 3 over x plus h. So write 3 over x plus h. All right, follow the formula for the difference quotient. I need to write the minus sign after it. And then they want me to subtract what? F of x from it. And f of x is simply this function right there, 3 over x. 3 over x. And when I'm done subtracting these two fractions, I will divide it by h. So let's make common denominators. These two fractions on top, they don't have a common denominator, so I can't subtract them as is. So multiply the first fraction by x over x. Multiply the second fraction by x plus h over x plus h. A quick way to make common multiples, right? Just multiply the bottom of the other fraction. All right, if I do that, this first one will turn into x times 3 and this times that. So I'll write that down over here, okay? So the first fraction turns into 3x over x times x plus h, right? The minus sign. And let's multiply these ones. 3 times x plus h over x times x plus h. Now here's my plan. I'm going to take care of this subtraction, and then what I will do is I will divide this by h. But instead of writing dividing by h, I'm going to write it as, I'm going to multiply by 1 over h. That's the same as dividing by h. So let's do the subtraction of these two rational expressions. So let's see, the numerator will be 3x minus 3 times x plus h. So if I write that out, 1 second, I'll make it a gigantic big fraction right here. That will be 3x. Let us distribute this. Let's distribute this negative 3. Just gonna make this the sign of 3. Look, I'm gonna say that this is a negative 3 that we're distributing. And that's gonna give us minus 3x and what? Minus 3h. All over that same denominator of x times x plus h. Let's bring this multiplication of 1 over h2. Okay, write this down. Okay, let's see if we can simplify anything on top of this fraction. Notice that we can cancel out this 3x and this negative 3x. So those are gone. So what I have left is negative 3h over the same denominator. And we're multiplying this by 1 over h. All right, look. On top of the left fraction, we have h. In the bottom of this right fraction, we have h. So those h's will now cancel out. Gone, gone. So my final difference quotient, simplified all the way, is negative 3 over x times x plus h. Now, it's time for us to plug in h equals 0 into this function, because remember, the derivative is the limit as h approaches 0 of simplified difference quotient, right? So what we now need to do is plug in 0 into h. So let's plug in 0 into h. So that will be f prime of x equals negative 3 over x times x plus 0, which is negative 3 over x times x, right? Well, but x times x is what? X squared. So I'm going to write down that f prime of x is negative 3 over x squared. Let me clean this up a little bit, okay, because we found what we want, but I used up all the room already. All right, so I'm going to make this a little bit smaller on the side. Now look, we did all that work because we needed this f prime of x. This is what we really needed. Think of that as like a function maker, okay? Not function, slope maker. If we have this f prime of x, we can find the slope of this tangent line. So write down that slope of the tangent line at x equals 6 is going to be f prime of 6. So you need to plug in 6 into this function. So that's going to be negative 3 over 6 squared, okay? So you do all this derivative because you want to find the slope of the tangent line. Let's evaluate what this is. This is going to be negative 3 over 36. And if you reduce that fraction, you get the slope to be negative 1 over 12. Okay? Now, this is like my treasure box, okay? This is what I need to write the equation of a tangent line. So, I'll show you how we finish this up. I'll bring this down, okay? I'll bring this down over here so that I can do the final answer. You learn in pre-calculus class that a point slope form of a linear function is y minus y1 equals m times x minus x1. In this equation, x1 and y1 stand for a point, okay? x1 and y1 stand for a point, and we have that. So this x1 is 6 and y1 is half, okay? Because we have an ordered pair at 6 comma half, right? So let me do all the plugging in, okay? So x1 is 6. So I'm going to plug in 6 right in here. What's next? Y1 is half. I'm going to plug in y1 right there. And lastly, the one that took us a long time to find, m is negative 1 over 12. I'm plugging right there. Okay, so here's my final answer. Okay, y minus half equals negative 1 over 12 times x minus 6. So this equation is in point slope form. You may stop there. Okay, this is what we can say to be our final answer. Sometimes, maybe my math lab, they may ask you to write this in slope-intercept form. If you want to write this in slope-intercept form, then you will want to distribute. Okay, I'll continue. Y minus half equals negative 1 over 12x plus half, right? Because negative times negative is positive. And if I get 6 over 12, that's half. Last thing to do is add half to both sides. See, we're doing extra step here, just in case someone wants you to write the answer in slow intercept form. Y comes out to be negative 1 over 12x. Half plus half is 1 whole. So, two different equations that I circled in pink. Both are fine. But if you stop right there on your exam, I'm happy with that too, because I don't want you to make an extra step, because that's a possibility of making another little mistake, right? So this is fine. But if your homework wants you to go all the way down to slope intercept form, then you will distribute and add or subtract this value that's being next to the y value. But that's how you can write an equation of a tangent line using the derivative.